Hi, Randal Schwartz here. I'm excited to present this video, originally created by Notebook LM. I think it contains a lot of valuable information that you'll find useful. As I move forward, I'm pivoting all my projects to focus on signals, and I wanted to share this resource with you as part of that transition. Enjoy the video.
All right, let's talk about Flutter state management. You know it can be a real headache sometimes. Well, today, we're going to dive into a solution that's not just simple, but incredibly powerful, and it's really changing how we build apps. It's called Signals Dart. Let's get right into it.
Yeah, if you're a Flutter developer, this question probably hits close to home, right? That feeling of always having to remember to call setState just to make sure your UI actually updates. I mean, it works, but you have to wonder, isn't there a better, more automatic way to do this?
So, to really get why Signals is such a big deal, it helps to take a quick look at the journey of how we even got to this point. Think of it like a mini history lesson on state management, starting from square one. And it all starts here, with the classic setState. This is the original, the manual lever you have to pull every single time. You change a value, you call setState, and you're explicitly telling Flutter, hey, this thing changed, you need to rebuild. It's direct, for sure, but the entire burden is on you, the developer, to remember to do it. Okay, so then things got a little better. We got tools like ValueNotifier, which was a really nice step forward. It lets you put your state into a neat little container. But it still comes with its own boilerplate, you know? You have to wrap your widgets in a value listenable builder, which can really start to clutter up your UI code with all that nesting. And that brings us to Signals Dart. And this isn't just another small improvement, it's a true paradigm shift. We're moving away from manually telling the UI to update and stepping into a world of automatic, effortless reactivity. So, what is it really? Well, the official description is a fine-grained reactivity system. Now that sounds fancy, but all it really means is that it knows exactly which little piece of your UI depends on which piece of data. And the best part? It tracks all those connections for you, automatically. And when you don't need a connection anymore, it just cleans it up. No memory leaks. And the magic behind it really comes down to these four core ideas. You get that fine-grained reactivity, so no more rebuilding huge chunks of your UI for one tiny text change. It's super efficient because of lazy evaluation. It literally does no work until a value is actually asked for. Plus, it's 100% Dart native, so it just works everywhere. And the API is just so simple and clean. Okay, the absolute best way to understand this is to think of a spreadsheet. Seriously, a signal is like a single cell, say A1, where you just type a value. A computed is like another cell, C1, that has a formula in it, like equals A1 plus B1. Now, when you change the number in A1, what happens to C1? It just updates, automatically. You don't have to tell it to. That is reactivity. To really get started, you only need to wrap your head around three core building blocks. These three functions, signal, computed, and effect, are pretty much all you need to handle almost any kind of app logic you can think of. Let's break them down. First up, we have the most basic unit of them all, the signal. You can just think of it as a box that holds a value. That's it, a value that can change. The key thing to remember is you always interact with it using the .value property. That's how you read from it, and that's how you write to it. And here's what that looks like in code. It really could not be any cleaner. You create a signal, give it a starting value. To see what's inside, you just ask for .value. To change it, you just assign a new value to .value. So simple, so readable. Now, this is where the real magic starts to happen, with computed. A computed signal doesn't have its own value. Instead, it calculates its value based on other signals. You give it a function, and it's smart enough to figure out which signals you're using inside. Then, whenever one of those signals changes, the computed value just updates itself. This is a perfect example. We've got two basic signals, name and surname. Then we make a full name computed signal that just combines them. Now if we later change name.value to John, that full name signal automatically becomes John Doe. No listeners, no extra code, it just works. And the third piece of the puzzle is the effect. Now an effect is different. It doesn't create a new value. Its whole purpose in life is to run some code whenever a signal it depends on changes. This is your go-to tool for side effects, things like printing to the console, making a network request, or saving something to a database. All right, so the theory is cool, but how does this actually help us in a real Flutter app? Well, this is where we see one of the biggest wins of all. It's a concept called surgical rendering. I mean, just look at the difference here. This says it all. On the left, you've got the old way with Value Listenable Builder, all that nesting and boilerplate code. And on the right, with signals, it's one clean, simple line. You just call .watch context on your signal, and that's it. That one text widget will now rebuild itself whenever the count changes. It's beautiful.
And that's exactly what surgical rendering means. Instead of using a sledgehammer like setState that can cause a big part of your widget tree to rebuild, signals give you a scalpel. You can target the exact widget that needs to change and leave everything else alone. The performance gains you get from this are just huge.
And Signals isn't just for simple counters and text fields. It's got some really elegant solutions for more complex, real-world problems. Let's just quickly touch on two of them, how it handles async data and something called batching.
You know the drill, right? Fetching data from an API can be a pain. You gotta juggle loading states, error states, and the final data. Well, Signals has this beautiful thing called async state that models this perfectly. It cleanly represents whether you're loading, you have data, or you have an error. It makes building reactive async UIs so much cleaner.
And then there's batch. Okay, imagine you need to update a user's first name and last name at the same time. Normally, that would trigger two separate updates, but with the batch function, you can group them together so your UI only rebuilds once after both changes are done. It's a fantastic little tool for optimization.
So let's zoom out for a second. We've seen how it works, but what's the big picture here? Why does this matter for you as a Flutter developer?
It really just boils down to this. You end up writing way less code. You get amazing performance right out of the box because of that surgical rendering. Your state updates just happen, automatically and efficiently. And honestly, the API is so simple and flexible you could start adding it to your projects today. When you look at the simplicity, the power, and the massive performance benefits, Signals Dart makes a really strong case. It solves so many of our common pain points in a way that just feels right. So the question I want to leave you with is this. Is this the future of state management in Flutter?